Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 15 of our May LeetCode challenge, and the problem that's been given to us today is the maximum sum circular subarray problem. Again, if you want to try solving this problem on your own, you can pause this video and check out the LeetCode link in the description below, and let's get started. So the problem statement is that given a circular array C of integers represented by A, you need to find the maximum possible sum of a non-empty subarray of C. Here, a circular array means that the end of the array connects to the beginning of the array. Basically, what it means is sort of just loops forward. And there are a few other constraints that you could sort of pause this video and check it out on your own. But basically, what they are suggesting is that if you are looping, you can only loop once. You can't loop over and over again, because if you do, you would either have a negative infinity as your total sum or positive infinity as a total sum. So we solved a similar problem like this before, which was the maximum contiguous sum of our subarray, and you should actually check out that video because we're going to be using a few of those approaches in this video as well. But the only difference between that and this problem is that there wasn't any constraint of circular arrays. Rather, over here we had that constraint. So let's go ahead and look at our examples. So the first example which has been given to us is an array which has 1, -2, 3, and -2. So you can see over here that the maximum sum that we can obtain is just by selecting the third element itself, and that's the output. Now let's go ahead and look at the second example which we have. So the second example is actually has that looping property that we just discussed before, where you would not take 5 minus 3 and 5. Rather, what you would do is you will try to sum up 5 and 5, which is 10, and that's the total, that's the maximum output that you can gain. So before we start getting into the example number 2, let's just try solving example number 1. So that's actually pretty straightforward. It seems like a linear problem itself, and the name of the algorithm that we're going to be leveraging again is the Kardani's algorithm. I think I might be butchering the pronunciation, but that's okay. So let's just go ahead and try implementing a linear solution, and let's build our intuition out of that, and build our logic from there. So we start with the base condition. It's just going to be if nothing's been given to us, then we return 0. In the Kardani's algorithm, it's pretty straightforward. You maintain two variables, which is you maintain what's the current max that you have and the max so far that you've had. So let's just go ahead and create two variables. Let's call it current max, which is, I'm just going to assign the first variable, so I don't have to deal with nuns or infinites. And the second value that I want to give is the maximum so far, which I'll just denote as mx. So the way we would go with Kardani's algorithm would be that you'll iterate through all the values, and do note I'm not iterating through 0 to n, rather I'm just iterating from the first from 1 to n minus 1. So the way you would sort of move forward with this is that you will sort of update the current max based on whatever's the max that you've encountered so far, which is either the num itself or the current max plus the number. And then you go ahead and update the maximum that you have so far. So this is something that you would want to update, which is basically either the current max is going to be the max or the max that you already have. And eventually what we used to do is that we used to just return the maximum value. Now this is pretty straightforward, and this is actually an easy solution. But now let's put in the constraint of a circular subarray also coming into the picture. Now let's try to think about this and try to perceive a bit of formulation. Now the hint which has been given to us is that you can sort of use something like the Kardani's algorithm itself. But the way we sort of go about it is, if you look at this entire sum, the total sum of this array is going to be 7. And the reason for that is that you add 5 plus minus 3 plus 5, which is 7. But when you think about it, it sort of makes sense that if you maintain the minimum as well as the maximum, what that would do for you is, well, the maximum which would be returned in our case would be 7. But if we take the minimum also into account, the minimum sort of helps us understand what's the minimum that we've encountered in our as a contiguous subarray. So what's that block of minimum which was blocking everything? And what if we exclude that minimum? So in this example, if we take 5 and 5 over here and just remove -3, what that would do for us is that it would give us 10, which is pretty straightforward. So what if we go ahead and remove that -3? But it's a little difficult to, just remove values out. So what if we maintain what's the minimum as well? So we already maintained the maximum, but what if we maintain the minimum as well? Well, if we have the minimum contiguous subarray with us, what we can do is we can just subtract it with the total, or rather add the absolute of that with the sum of the total array, and that would sort of help us understand what would happen if that, contiguous subarray wasn't there. So in essence, over here, the total sum is 7. And what if we take this -3, which is the minimum contiguous subarray which we've encountered so far, and we add the absolutes together. So 7 plus 3 would be equal to 10, and that's the output that we're looking for. And that's basically the intuition that you would want to go with just to solve this entire solution. So let's go ahead and implement that. So it's pretty straightforward. What I'm going to do is I'm just going to create 2 more variables. I'm just going to call current min, and also I'm going to call something as min. The only difference between the max versus the min is just going to be, instead of calculating the maximum, I'm just going to calculate the minimum. That's actually pretty straightforward. Not that many complications there. And let's go ahead and update this as well, and so on with mn and also with mn over here. Yeah, so basically what you're doing now is that you have the current minimum that you can get from the contiguous subarray, and you have the maximum contiguous subarray sum. So we just want to add a quick condition, which is actually pretty straightforward, that if the sum of a is equal to current of mn, well, in that case you just want to return the max. That's actually pretty straightforward, but the bulk of the code, the main logic sort of comes over here. So what if you have, what's the maximum between the maximum that you've encountered so far? What's the maximum between, what if we do not consider the minimum contiguous subarray? So what if the maximum is actually going to be the solution? And that's basically it. So that's basically your intuition. So you take into consideration what's the maximum, you take into consideration what's the minimum. With minimum, you just remove it from the array and you say, hey, what if it wasn't there? What if it didn't exist? What would it be maximum than the actual maximum that we've calculated? If so, then return that. Otherwise, just return the maximum. And that's basically it. So let's go ahead and run this code, and hopefully this should run fine. And let's just go ahead and submit this, and hopefully this should get submitted as well. And you can see it got submitted. Cool. So I can see this problem actually giving a lot of problems to a lot of people. And the reason behind that would be just because they would not think about using Katane's algorithm to just solve this problem. But usually inside something like contiguous subarrays, that's something that you would want to do. You can try to do this in O(n) square as well. There's no problems with that. But essentially, I would assume that the interviewer would like you to solve this in O of n solution. Cool. So if you did have any comments, or you have something that you didn't understand, do leave it in the comment section below. I'll try to get back to you as soon as I can. And again, if you did like this video, do give a like and do subscribe to our channel. We are discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.